We're going to look at some division problems, and we'll start with the division of a polynomial by a monomial, which would be the goal of this segment. Now, of course, I'm going to start out with a little bit of review. Let's recall the product rule and how it works. Not the product rule, the quotient rule. If we have something like 12x to the 15th divided by 3x to the 4th, we're going to deal with this division problem, the monomial divided by the monomial, by taking the 12 divided by 3, and we're going to deal with the powers by keeping the base x and subtracting the exponents. So we'll have 15 minus 4, and that will leave us with a 4 times x to the 11th power. Something else to think about is fractions and how they work. If you have something like 2/3 plus, let's say 5/3, we notice that they have the same denominator. And since they already have the same denominator, we're going to add the numerators, 2 plus 5, and put them over the common denominator, and we can go on from there. What I want you to take out of this is we could just as well go from this side back to the beginning if we started with the 2 plus 5 over 3. And we're going to use that idea of breaking up a fraction when we do division. And finally, I want to remind you what the meaning behind division involves, or what is involved in the meaning behind division. If we have 8 divided by 2, we get 4. That means that 4 times 2 is 8. And that's, whether you remember it or not, initially how most people probably learn division. Now, what we need to do is put these ideas together in working with polynomials. And we'll do this with a polynomial divided by a monomial together. And I just want to start by walking through an example. Let's take something like 18x cubed plus 24x squared and divide it by 6x. Okay? Thinking to the idea of breaking up a fraction, right now we have sum, and it's over one denominator. You can think of it as being over a common denominator, if that will help you. And we'll write that as 18x cubed divided by 6x plus 24x squared divided by 6x. So we're breaking up what we had before into two terms added together. What we're going to do then is complete the division with this piece and complete the division with this piece. And this is going back to the quotient rule. So 18 divided by 6 is 3. And then we'll have x raised to the power 3 minus 1, because remember the x in the denominator has a power of 1. And adding to that, 24 divided by 6, which must be 4. And we'll have x to the power 2 minus 1. Well, that leaves us with 3x squared plus 4x. Now, it would be nice to be able to check this, and that's where that third idea about the meaning of division comes into play. What we have when we say 8 divided by 2 equals 4 means that 4 times 2 equals 8. We could write this in words. We have the dividend divided by the divisor, and that gives us a quotient. That's for the first half. For the second side, we could say, well then, the quotient, that was the 4, times the divisor, better give us back our dividend if all is right in the world, whatever was on top. You can use this to check your answers when you do a division of this nature. So let's do that. We had our quotient, which was 3x. So let me just write a check mark over here so see what we're doing. We had a 3x squared plus a 4x. That was our answer, our quotient. And we're going to multiply that by our divisor, whatever was on bottom, and that was, or rather in the denominator, if we want to use technical language, 6x. This is going to be a candidate for the distributive property. So we'll have 18, 6 times 3 is 18, x times x squared is x cubed, plus a 24x squared. And if all is right in the world and with this problem, this will be the same as the numerator of our original problem statement, and it is, so our answer checks out.